So we're here in North Sydney, and we're doing the cocoon system on the front bricks of a place. They've all got salt damage. You can see here the mortar is coming out of the joints there. Alright, it's starting to get quite bad. So before we do the injection for the rising damp and before they repoint, we're going to be doing the cocoon system to remove the salt from the wall, because if you do any repairs while there's salt in the wall, the damage will reoccur. The reason the damage reoccurs is because sodium chloride is salt, right, which is in the wall, and when sodium chloride comes in contact with water, the sodium and the chloride actually separate, so the two molecules separate, and sodium will be surrounded by the water, so H2O, hydrogen, oxygen, so I can't remember which one it is, but for example sake, the oxygen surrounds the sodium molecule and isolates that inside a ball of water, like a buckyball kind of thing, and the chloride is the same thing, except the hydrogen will surround that, so the water will surround the molecules of the sodium and the chloride, depending on which one they are, by the hydrogen or the oxygen. And then what happens when the water evaporates from the wall, so when the heat touches the water molecule becomes higher in energy, which makes it lighter than air and evaporates. And the sodium chloride will slap back together and crystallize. Okay, so as that happens, millions of times, you get salt crystals through the wall, which when the salt crystals get between the bonds of the sand cement, it pushes the bonds of the sand cement apart, and you end up with dust in your mortar joints, and they'll end up dropping down. Okay, now what happens with salt, because salt is hygroscopic, meaning it bonds with water very well, it attracts moisture from the atmosphere. So if you've got a humid day, for example it's raining, there's other videos where I show you this, the water vapor in the air has a higher energy, so it's floating, it's lighter than air. And when it comes in contact with a cold substrate, the cold substrate will take some of that energy away from the water molecule, and the water will turn from a vapor into a liquid again. When it's a liquid and it's enough of the water happening, it will surround the sodium and chloride and separate them again and isolate the sodium molecule and the chloride molecule, and the walls will get wet. So inside your house, when you've got rendered walls, if you've got a lot of salt in them, the walls can look like they're sweating with water, and that's the reason why, is because the sodium and the chloride will attract the moisture, and when the moisture from the atmosphere turns into a liquid again, it will get held by the salts, the sodium chloride on the wall. So the way the cocoon works is the water from the cocoon obviously goes into the wall, and the sodium chloride molecules are separated, and they will float in the H2O, and as the water comes through the wall to evaporate, at the surface the water will become a vapor again and leave, and the sodium and chloride will crystallize in the cocoon. Alright, so inside the paper, the sodium and chloride will crystallize and it will be held in there. Now when you remove the paper after so usually a month process, so the proper way to do it is to take a sample of the wall and put it through a chromatography machine, measure the salt content, do your cocoon. Usually you do a 2-week process, remove it, put a new coat on, leave it for another 2 weeks until it's dry, then remove the cocoon again. And normally we don't test it because that's usually enough, but sometimes if you're in a critical place, or it's a valuable job or whatever, or it's near the ocean, then it's worth testing the wall before and after the cocoon process, and if there is more salt in the wall after the cocoon process is finished, you can reapply the cocoon and keep going until the salt has been removed from the wall. Okay, so normally in residential situations, 2 coats is enough, which is a month's treatment to pull the salt out of the wall. Now you can see here this is already thinning up. All right, it's already dense, right? That's because the moisture from the cocoon's already gone into the wall. So you can see here we put it on quite thick, right? You can see how thick that is. Within a day it'll be quite thin, and the moisture will go in there and dilute the brickwork and dissolve the salt, and as the obviously water evaporates, the salts will come out, and that's it in a nutshell. Cocoon goes on about 10 mil thick, whatever. It was recommended 10 mil thick. If it's too thin, it's difficult to get off, it's not going to do its job properly. So yeah, 10 mil on, and that's it. So it's a pretty simple process, and it can save your building from falling down.